So hey guys, welcome to Clear and Crisp Coding, and in this video we will be discussing the solution of Codeforces educational round 90 problem A, the donut shop. So here is the problem statement. You can read the problem, but if I explain you the problem in simple terms without missing any important point, then the problem is something like this. So here we have two types of shop. One is a retail shop, another one is a bulk shop. In retail we can buy each donut for A rupees, A dollars, and in bulk one we have to buy a box consisting of B donuts, such that the total box cost is C. So if you want to buy X donuts from this shop, we have to buy the smallest number of boxes, such that the total number of donuts, which is the sum of donuts in all of these blocks, is greater than or equal to X. So we will come to this point more when we will see the some solution. So just now let's move. What we need to find is given here. So we need to find is that we need to give some value of donuts which we need to buy from both of the shops, such that if we buy the donut from shop 1, then it will cost us less as compared to shop 2, and we have to give another value of number of donuts such that we buy the same number of donuts from shop 1 and shop 2. The shop 2 one would cost us less. So here is the sample input output. So now let's get to the explanation. So in this question we basically had to handle these cases, these three important cases. So this is the cost which we need to pay after buying the donuts from shop 1, and this is the cost which we need to pay after buying X donuts from shop 2. So these are basically buying X donuts from shop 1 and X from shop 2. And in the question we should definitely notice this constraint, that this should be B. I again miswrote it. So this should be B. This should not be A. As in the question it is given that B is greater than or equal to 2. So this was a really important point in the upcoming steps which we would be doing. So B was greater than or equal to 2. So now let's start with the individual cases. So for the first case, if we see that C is less than A, that means the AX, the cost which we need to pay to the first shop, and BX into C. So according to this A is greater than C and C is less than A, and so this value and this value only if we see, so this is greater than this. And now let's just compare the remaining part. So if we see for B greater than 2, that means this value would be 2, 3, 4. So we can always say that this would be greater because X is divided and X is divided by 1. It would be definitely greater. So since A is greater and X is also A is greater than C, and X is always greater than X by B, so this value would always be greater than this. If we take any value of X, we can definitely prove that this is smaller than this, and according to this case this value is already greater, so this would always be greater than this. So for the answer 1 is basically the case when we have to give the number of donuts such that the buying it from shop 1 is cheaper, and answer 2 is the answer which we have to give for the case when buying donut from shop 2 is cheaper. So in this case we have proved that we can take any value of X, then the cost which we have to pay to shop 1 and shop 2, this would definitely be like this. So we have to pay more to the shop 1 in any of the cases. So this was the first case. And for this other part, if we see again AX and X by B into C. So if we see, we have just proved that this is always greater for any value of X, since A is greater than B and this X is greater than X by B. So we can just take any value of X. So in my solution I just took 1, which was the really simple. So this was the entire proof for this case, that this would always be greater than this. AX would always be greater than this if A is greater than C and B is greater than or equal to 2, it is given. So this concludes the case 1. So now let's move to the case number 2. So here if we see, this same expression is the main key point of this solution, and X by B into C. So we have these two values. So here C is equal to A, that means these two are equal. So this can be removed. So this, not actually it is removed. So we are basically comparing here. So file comparison, if we see these two are equal, so which one is greater amongst these two is decided only by these terms. right? And according to this equality, this is always greater. So since a is equal to c, we can write a as c also. Cx is greater than x by b into c. The c gets cancelled on both sides, so x is always greater than b. So in this case, basically, this was a1, this one is 2, so a1 is always greater than a2. So here this is again proof. This is also a really great observation and great proof that we can take any value of x and this condition would always be satisfied. But again we have to make sure of one more thing, that what if we put x, no, that would be fine. Okay, I missed just the thing. So this is the case for all of the values, it would definitely be true. Since this inequality hold, these are equal, so this will always be greater. So the answer for the first, that means the value of x is that this is smaller, is not possible. And for the second, we can take again any value. I here have taken b. You can take your own value, it would be really more simpler and according to your need. And now let's get to the last case, which was a little bit tricky, which was here. Let me just clear all this. So now if you again see ax and x by b into c, this was the main equation which we have to compare throughout this question. So here if we see that if c is greater than a, that means c is greater than a, this inequality that x by b, this always hold. We can't just see at any point this does not hold. So this x will always be greater than this. So here if we see the answer 1, that means this being less than this is always true. Now let's see how. So is not always true actually. It is true for the value of x equal to 1. If we put in these equation x equal to 1, so a into 1, and this would be 1 by b, this would be the seal of it into c. So that means this value would be a, and this would be like 1 only, because b is greater than or equal to 2. So this is, here we have to take the seal, because it is in the question, it is given that we have to buy the donut from the shop with the smallest number of boxes such that the total number of donuts are greater than or equal to. So that means if a box contains 3 and we require 2, then we have to buy entire one box. So that is why it is coming as 2 by 3, the seal of this 2 by 3. So 1 by b, so here I mean we have to buy 1 in this case if we see, and b is somewhat greater than or equal to 2. So we are taking b3 here, so this should be 1 into c, and we have seen that, assume that c is greater than a, so this is always valid, and the answer for 1 satisfies this condition. So this was the answer for the first part. And again if we see for the second, though, so we have to check that this condition, this should be less in the second, that means this value, that means the a2 and this is a1, so a2 is less than a1, we have to check. So if we see what could be the possible value, so see if a into b is greater than c, then the answer 2 would be b. So suppose we put b here, that means a into b is greater than or equal to b by b into c. So if we see this get cancelled, so a into b is greater than c. So if this condition is true, then the answer for this is b, otherwise the answer for this is -1. So this was all the 3 cases, and this was the main formula which we need to observe. So now let's get to the code for better clarity. In the code also, I've just implemented those 3 cases in separate if-else blocks. So if this is a is greater, both are equal, or if c is greater, I'm just implementing the same. You can see the explanation here. So if you have any doubt, do let me know in the comment section, and subscribe to the channel, as I would be regularly posting the competitive programming material for various contests. And if you like the video, do give it a thumbs up and subscribe to the channel by the icon shown somewhere here. Thank you guys, thank you for watching.